Hello, everyone. My name is Lucia Capogna, and today I'll take you through a brief panoramic related to operational technology, cybersecurity for railway applications. I work for Sistra, and Sistra is one of the world's leading engineering consulting group specialized in public transport and mobility solutions. We are the signature team providing a safe and resilient transport and infrastructure solution. And we are present in all type of transport solution, really. Who am I? Why today I'm doing this presentation? I'm the cybersecurity and software assurance team leader for my company. I have over 17 years of experience around multiple discipline, software, cybersecurity, requirements management with a foot in the safety, one in the cyber. So I'm a bit of controversial figure that works for standardization groups as well. So I'm actively involved in the development of safety standards like the 50129 that is largely used in this industry for safety. The cybersecurity standard, both CENELEC technical specification and the international standard that is under development for cybersecurity and software as well. And recently I've been appointed as a Royal Academy of Engineering visiting professor for the University of Birmingham in cybersecurity and operational technology. Well, I would like to start with an introduction, and every introduction, as usual, starts with the obvious. So digitalization, what we are facing in this moment, in this specific period of the industry is facing is digitalization introduction. So we are introducing digitalization everywhere. It's an exponential introduction of new solutions, more advanced, that may increase the efficiency through automation, is more scalable, flexible, supports better solutions that we need to implement, and gives us a better control around. But it's also more sustainable for a number of reasons. Improves collaborations, and if well done and properly scheduled, will also support cost saving and competitive advantages across not only this industry. This is something that may be cross industry. However, every good thing arrives also with bad news to a degree. Digitalization evolution introduce also new things, new problems. These problems are risks that evolve over time, are risks that are not fixed in one single moment, but may change with time, are cybersecurity risks, but also requires a number of maintenance elements, improvements, and continuous investment that needs to be considered as part of the picture. So digitalization, it's a fact, it's happening. We cannot stop innovation. So how can we then deal with these new risks? Let's start understanding what is cybersecurity really. Why do we need it? We are technology dependent nowadays, not just in the operational context. I'm thinking more about what I do day by day. I manage my day using apps on phone, really, also the tasks, reminders, everything, appointments, school, meetings, everything, really everything. Many systems that were only mechanical are now digitalized and connected through the internet. We need, well, this is not just personal life, isn't it? This is true for the rail transport and infrastructures as well. So cybersecurity is important because it helps business and organizations to prevent costly and harmful cybersecurity attacks. It also helps preventing reputational damages that should not be neglected in this picture. It is crucial then to safeguard what? Data. Not only the personal one, also the business-related data from theft, loss, or manipulation. And it's where cybersecurity helps us, really. So what is then cybersecurity? There are multiple definitions you can find around. Well, one of the definitions is provided by the National Cybersecurity Center and says that cybersecurity is how individuals and organizations reduce the risks of cyber attack. When we look into more technical standards, something more oriented to operational technology, we can find a sort of different set of definitions, but all of them point to the fact that security is a condition that of system resources being free from unauthorized access and from unauthorized or accidental change, destruction, or loss. Cybersecurity in the rail application as a discipline, as activities, is seen as a set of activities. It's not a single step. It's not just a measure, an activity per se. No, it's a set of activities and measures that are taken with the objective to prevent, detect, react to what? To issues that may derive from unauthorized access or cyber attack that can lead to an accident and potentially lead to unsafe situation or railway application performance degradation. This is the definition that as you can find in the TS 50701 is a technical specification that has been developed by Senelec with the aim to address cybersecurity for railway applications. We will see this later on a bit better. Well, I started talking about operational technology, but what is the operational technology? And what is then as opposite the information technology? Why we are creating this distinction between the two? Well, informational technology refers to anything related to computer technology, and this can be both hardware and software. When we talk about operational technology, we are talking about the use of hardware and software to monitor what? And monitor and control physical processes. That can be also the infrastructure itself. Where the problem really lies with when OT device control the physical world. So while the IT manages instead the data. So essentially, if the operational technology is controlled by informational technology, then it is subject to cybersecurity risks and attacks. So the IT security has the scope to protect data, where instead the operational security has the scope to protect the industrial systems and networks from attacks. Is it so specific, the boundary between these two? Well, not really. As I said, there is the possibility for the information technology to control the operational technology. And we are introducing more and more information technology elements in the operational context. So this boundary in reality is very fuzzy, is not as specific. Information technology is used with the operational technology, and the operational technology may be used to feedback info or may provide a number of other elements into the informational technology. So it's not a very separated world where you have this junction between the two. This must be taken in consideration. What are the risks we mentioned before then? The risk is defined as for safety, definitely, is defined as as a likelihood that a specific threat will exploit a vulnerability with a specific consequence. So it's a two-dimensional matrix where you can identify if your risk is acceptable, not acceptable, in line with your tolerability criteria. The vulnerability in cybersecurity is defined as a weakness. It's a weakness in the system, can be part of the design, the implementation, but also in the operation management. Now, cybersecurity threat landscape is always evolving. So we will always have known and unknown vulnerabilities, given that a lot of them are still hidden or that the technology evolves over time. So once identified, a mitigation and proved that it is effective, we are in reality mitigating only a number of them. This is what happens classically in the risk assessment. We identify a risk. It is not in the tolerability area according to our tolerability criteria. We find a mitigation. We take the risk down to a level of risk that is acceptable, and that's all. This is a classical approach, isn't it? But with this new kind of issues where the vulnerabilities can be used to change the risk, and having the knowledge that not all of them are known in a specific moment, what can happen is that in a specific instant of time, a new vulnerability is discovered. So what happens then? Well, potentially, we can go back to a level of risk that is not acceptable anymore. We need to find a new mitigation, also called patch management in the cybersecurity world, and take down the risk again to a level that is acceptable. Well, is this then okay, 100% with the safety approach we have? Can we change the picture of how our system is implemented? Cybersecurity has a strong link with the safety if we are talking about the critical system. Can the safety then be impacted by a cybersecurity issue that is determined? Can we still say we are safe if we are not managing these kind of risks? Well, let's define the problem. So the problem, there are a number of facts. First of all, we are continuously introducing new digital systems in our solutions, and gradually we are also replacing a number of old systems, but we cannot ignore that legacy systems are still used. And all the systems that we are introducing or revamping are more connected and interconnected through the internet. So we have a risk around cybersecurity that cannot be ignored. One of the facts that we can share with multiple industries, not just in rail, it's that all the systems that we have are designed and built to achieve specific objects and targets around safety, reliability, availability, and functionality. But we don't set specific targets around security in most of the cases. So what do? We start designing, and we design a system that takes in consideration a lot of elements that come from safety. We are looking into the failures of the system with great detail to make sure that they are incorporated, solutions are incorporated into the design. So we end up having a system that looks into safety elements and is designed with both, with all these targets in mind. Another the fact that I would like to present is that in most of the cases, not always, but in most cases, cybersecurity is addressed separately from the system design and engineering. It seems a sort of external element. But when this happens, then a number of issues are found. And to mitigate those issues, we start adding a number of elements around our system to make sure we can protect the system and the operations in better, in an adequate manner. A lot of problems arise when cybersecurity and safety intersect. Why is that? Because they have completely different speed. We have safety that takes a long time for definition, approval. The process is very slow in that sense, where cybersecurity aims to have a very quick life cycle, trying to patch manage as soon as possible the issues that are found. So these are problems we need to deal with at a certain point. But the main questions around this definition of problem that I'm trying to present to you is, are the new risks, these cybersecurity risks introduced by the digitalization, managed properly and timely at the moment? We may have different opinions on that, but and we cannot generalize. Definitely, there are several set of examples that may confirm or not confirm ideas around this topic. However, another question arises: is this approach effective? Then we are putting something that comes later around our system, trying to protect the system. It's an additional piece of technology, additional elements that need to be added, adding another layer of complexity to our systems. Let's look a tiny bit better on the objective of the cybersecurity and its pillars. We said that something like that needs external, additional security technology, and is more costly and less effective than solutions that instead embed cybersecurity as part of their design, so security by design, if we like. To increase the resilience of our system, we should aim to move from an approach like this one that is reactive to the problems that are found to a specific moment in time that belong to the system and have not been addressed internally, to something that instead is more proactive, that reduces the cybersecurity and the safety risks as a part of, and is considered as part of the design. This should long-term reduce the cost and increase the efficiency and effectiveness of the cybersecurity. So today I'm not just presenting cybersecurity per se, but also explaining that we can apply cybersecurity we can have cybersecurity in different aspects. We may have cybersecurity as a reactive element or as a proactive element. Well, in my opinion, the proactive one leads to a better resilience for our systems and may be important to include cybersecurity into the processes and the development of the systems earlier in the life cycle than not later. Cybersecurity and safety may have different perspectives, may look at the same system with different goals, and they may define requirements that could go in contradiction somehow. But we are looking at the same picture. So it's a matter of perspective, but the object we are observing is the same. And the final goal is to have something that is available, reliable, and safe. And the cybersecurity may support all of these elements. So essentially, we should work together. But also, if it is not secure, we cannot confirm, we cannot guarantee that it is safe. So it's an element that should contribute to what we do day by day to make the systems better and more suitable for the goal we want to achieve. So what are the objectives of cybersecurity? Just to be more on the theoretical side, CIA stands for confidentiality, integrity, and availability of the data in the classic interpretation of those objectives. When we are in the operational context, we don't talk anymore about data, but data and how it is protected may impact the other elements of the system. So to protect the confidentiality of the data, the organizations need to make an effort to keep it secret or private and prevent that unauthorized access and disclosure happens on this data. In the operational context, if confidentiality is compromised, we risk that business information, critical information, are leaked. So this info can then be used for various scope, including damaging the organizational reputation or to gain access later on to the system itself, depending on the kind of data that are stolen in a way. The integrity instead aims to make sure that the data is trustworthy and free from tampering. If integrity is compromised, we may have different scenarios at the operational level, including what? Including potential safety impact. So we are changing the integrity of the info that are exchanged, essentially. And obviously, this leads also to cost and reputational damages. It's not limited to that. If something impacts on the safety, the impact doesn't stay with safety only. It's the main one, but extends to other areas. Even if the data is kept confidential and its integrity is maintained, it's often useless if the info are not available, if the systems are not available at the same time. So if data availability is compromised, key systems may be unavailable. And again, the business operations may be affected. We need also to consider that if the system is not available in a specific context, in specific scenarios, it can also lead to safety issues. So again, when one of these elements is compromised, the impact may affect other areas that are not the main one, but as a secondary effect may be affected. When we look into the informational technology, the priority usually is done to the confidentiality of the data. When we look into the operational context, in the operational technology context, usually the integrity and the availability have a better priority than not the confidentiality. This is just as a fact, as we usually define the goal around operational technology cybersecurity. Cybersecurity is very often seen and associated with the technology only, and sometimes is also confused with software. However, cybersecurity is based on three main pillars, which include the technology, it's important, but also people and processes. Specifically talking about people, I think everyone understands the importance of the processes. Everyone understands the importance of the technology and the role that it plays in cybersecurity, and not only. Regarding people, I think that it is important to underline that when looking at cybersecurity in general, they are considered one of the biggest weaknesses. Well, by fact, I think that is one of the most valuable assets for the organizations and can be our first line of defense. So all these elements need to work together properly and educate and empower people to identify, avoid, and react to cybersecurity attacks. It's important as much as looking into the right set of technology and processes adopted to achieve the cybersecurity goals. So cybersecurity is much more than technology. So what are the main aspects then we consider for cybersecurity? Well, first of all, we need to consider what. What do we need to protect and what vulnerabilities these assets have? Is it sufficient, though, to identify known vulnerabilities of specific assets only? Well, it's not sufficient. We don't work with elements that are taken in consideration in isolation. They are interconnected, so interfaces and other elements may be needed, considered as well. Another element that aspects that we need to consider is who can potentially perform an attack to our systems or to the railway, if we like. And what is their motivation? Why? Why they would perform an attack? All these elements are important because may determine what is the likelihood that something is happening. We can influence what the likelihood looks like in that sense. But also how can the attack be performed? What are the kind of skills that are needed to perform this attack? So essentially, we need to look into having a structured approach, defining what is the element, the systems that we need to defend, so the asset inventory and the vulnerabilities associated with every asset. It's the first step that we need to do. If you don't know what you need to protect, it's difficult to understand how to do it. Then the other element is who and what are the skills needed to attack, but also what kind of attack we may have. What is the motivation behind a possible attack? The consequence that the effect of the attack can have on our systems. You have seen CIA a second ago, the goal of the cybersecurity. What element are we going to consider in the consequence? What is the main impact we will have? And we need also to determine the mitigation. And if we are adopting existing mitigations and conditions, we need to make sure they are effective as well. They cannot be adopted by default. We need to understand if in the same context, if in the context we are analyzing, they are still effective. And if anything is changed since they were determined the first time. But also we may need, and I strongly advise that, to have in place an incident response and a recovery plan. Attacks can happen. There is no 100%, a system cannot be 100% secure. There are so many elements to be considered. If something happens, can we recover from the situation? And how? And other aspects in general. So what is an asset? We said the first thing is to determine the asset inventory. It's defined in many things. What I like the most is the last one, and it's anything that can be used to produce value for your organization. So assets can be tangible, but also intangible in a way. So can be hardware, can be software, can be information, data, technology components, systems, people, and much more. When we look into tangible assets, we discuss about hardware, technology component, whatever, but the intangible one, the humans, so the people, the data, the information, the software, still are part of the asset inventory. This is what we need to protect. But who and why wants to attack our systems then? This is called threat actor or malicious actor. It is a person or a group of people that take part in actions that have the goal to harm computers, devices, systems, or networks. And we can have multiple kind of actors: hackers, security experts, industrial spies, insiders, activists, script kiddies, terrorists, whatever. We can continue with this list. And definitely all the motivations may be completely different. They can do it for financial gain. They can be espionage, corporate or state-sponsored, can be for fun, can be for recognition, revenge, internal. I'm thinking about insiders, for example, someone that is really unhappy with the organization, has all the info to perform an attack. So all these elements needs to be taken in consideration. And how? There are multiple ways the systems can be attacked. Using malwares, one of which the most famous probably and the most frequent is ransomware. Can perform a denial of services attack, phishing, spoofing, identity-based attack, and others, including the supply chain attack. Cybersecurity measures are as strong as the weakest point. So if one of the suppliers does not really look into this element, then and creates weaknesses around the supply chain where all the chain is weak. So, but what do these attacks have in common? All of them have a component of social engineering. And social engineering is defined by Jenny Radcliffe as the manipulation of human factor with the scope to obtain unauthorized access to the resources, the asset, and whatever, and take advantage of that. Now, another element that we can find in the statistics is that 98% of those attacks can involve social engineering on some level. This explains how people may be really important in this context. We have a number of tools that can support us. Where the cybersecurity goal is to protect the operational technology from cyber attacks, the cybersecurity standards aim to support and provide guidelines around the management of those cybersecurity risks. It's not just a cybersecurity risk assessment, but it's the full process across the life cycle, from the consideration of the environment, the definition of the system under consideration, if you like, the asset inventory as well, and the identification of a structured approach across the life cycle that provides a number of steps for the risk assessment, but also for the assurance that the solutions, that the mitigations identified are as effective. And cybersecurity extends then as for safety in the operational context, in the maintenance of the systems too. For informational technology systems, we find that the ISO 27000X family and the NIST cybersecurity framework support the solutions. When we look into the operational technology systems, the main standard that is cross-industry is the 62443, but we also have something that is very specific for rail, that is the TS 50701, and very soon we will have the 63452 IC standard that is under development at the moment. So this ISA 62443 series provides a framework to address and to mitigate security vulnerabilities in the industrial automation and control systems. And instead, the 50701 is a technical specification that was issued for the first time in 2021, and has been the second version has been issued in 2023 to address minor comments. It applies to communication, signaling, processes, rolling stock and fixed installation domains, provides a reference to models and concept requirements, recommendations, and is very specific for rail, talks with the language we are used to. Also provides a means of interaction with safety. Looking into railway standards, this is a sort of high-level picture, is a simplification of what we have, and does not list all the available standards in rail, but just the main one around RAMs and cybersecurity at the moment and software. So if we look into 50126, that is one of the main standards in the rail, we know that this standard covers the full product development life cycle. And the same is for the 50126-2 and the 50129 that looks into the safety element, covers the full life cycle. When we look into the software standard, 50128, 50657, or 716 that will replace both of them from October 26, we look at the component level. Where does cybersecurity standards sit in this picture? Are they a component element? Are they a system element? As I said at the beginning, very often cybersecurity is confused with software, but there is a huge distinction between the two. Definitely software is an important part that should be considered by cybersecurity. However, software is a component level activity, where instead cybersecurity is a system element, should be considered at the system level, and extends and provides requirements to the component level as well. All these elements need to work together if we want to have a successful digitalization in place. Another tool that can be used is the risk assessment, definitely. This one is a picture that I extracted from the 62443-3-2, that is the standard, the specific standard in the 62443 series that look into the risk assessment itself. And it's defined as a process that systematically identifies potential vulnerabilities to valuable system resources. What are these valuable system resources? The assets that we discussed before, and threats to those resources. Quantifies loss of exposures and the consequences based on probability of occurrence, and optionally recommends how to allocate resources to countermeasures to minimize total exposure. So, in my opinion, the risk assessment process helps prioritizing the identified risks. We cannot probably address all of them exhaustively, but you can identify those that are not bearable for your operations, and helps estimating number of things, including the consequences. So that would help understanding how to prioritize them. Another important tool is people, we said, trained people. Cybersecurity is a job for everyone. There are a number of people that are involved that use, develop, or maintain our systems. There are people that actively play a role in the design and the building of the system, but it's only one group of people. Important, essential to develop the right system with the right requirements, but there are other people that need to be aware about cybersecurity, and are people that own and operate the system, maintain the system, or use the system. But there are also people that are indirectly involved with what we do that needs to know about cybersecurity. Thinking about investigation around a rail accident, for example. Also, this group of people needs to know about cybersecurity too, to improve what we already have and to consider if it's one of the causes of the accident as well. So just to make an example, but I'm sure that we can identify more people that belong to the group that indirectly is involved with the systems we develop. Essentially, training people means to move people that don't know they don't know into areas where they at least know they don't know, so they can do something in that regard, call the right people, address the problem with the right people, or trying to improve their knowledge to move in an area where they know what they know. And maybe further have an advanced knowledge around cybersecurity that at the point that becomes unconscious knowledge as well. Cybersecurity is not just does not just require cybersecurity experts, but requires understanding from other disciplines on how cybersecurity can impact on what they're doing and the outcome of their job. I would like to add a few further considerations around what we are living at the moment. We have a number of legacy systems that are very often unpatched and are still used and essential for the operations. So what does it mean? It's one of the weaknesses, one of the elements that can be used to attack the railway. Another element that is that usually systems are developed in isolation, do not consider the context itself, 100% do not consider other systems interaction and the dependencies that we can have between those systems. Essentially, the integration aspects may add additional risks, but very often they are neglected because it's a matter of responsibilities, how we want to define the boundaries for the accountability, responsibilities around what we do. And definitely there is a lack of cybersecurity experts in the industry, in the rail industry specifically, but it's so important, this risk, this element, that ENISA, that is the European agency that looks into cybersecurity for the European community, has defined this as a second risk in the ranking for 2030. But there is also lack of awareness across other disciplines. If we don't recognize that there is a problem, and if we don't have a good understanding, independently from the discipline we are talking about, cybersecurity. Cybersecurity may be selected as a second element, not embedded in the design, but arrives later with a reactive approach that may be not effective long term. And also, standards and guidelines are still considered as a cost. It's not always the case, I'm generalizing definitely, but in most of the cases it's considered a cost, where instead they should guide into the right direction. So very often they are not properly applied for a number of reasons. One, because maybe we are trying to reduce the cost around things, or because there is a misinterpretation due to lack of understanding. So having a better understanding around the cybersecurity may reduce the risks also in misinterpretation, and the standards may be applied better. Okay, so let's conclude on what we said today. So definitely we cannot say that so there is no system that is secured 100%. Why? Because we have seen how the vulnerabilities change over time. There is, in a specific moment in time, there is just a number of vulnerabilities that is uncovered. Then many others are not known yet. Then there are multiple aspects we need to consider when evaluating the security of a system. And definitely cybersecurity risk assessment may help understanding also what is the impact if an attack is successfully performed on our system. This will help also identify and prioritize the measures that should be used to protect the system itself. Without forgetting that if we are adopting something that is already in place, we need to reevaluate if it's still effective. The attacks that are performed are becoming more and more complex and more sophisticated, so we need to keep up with knowledge on our side. So the good guys need to know better. Otherwise, we may be exposed to very complex attack that will not help identifying them. 90% of those attacks may be prevented with the right knowledge. And remember, 98% of the attack involve social engineering, so probably we can do even better. In general, what I would like to underline is that the operational technology, cybersecurity, shall protect safe, reliable, and available physical operations. So should be embedded in what we do from the beginning up to the end and this mission of our systems. Thank you very much. So I think we arrived at the end of the presentation. Stop sharing.
Thank you very much, Lucia. So yeah, well, there's not many questions in the chat, so if anyone's got any, feel free to either type them in or raise your hand. There's only one question really, which is that the CIA is obviously a familiar acronym. Yes. Is that an acronym that you've coined, and was it deliberate?
No, I didn't. Actually, it's the triad for cybersecurity that has unfortunately the same name.
Okie dokie. Has anyone got anything they'd like to ask Lucia? Raise your hand now. There's one that's come in the chat from Anthony, which is, what threats do we face from not creating our own, i.e. UK network devices?
Do you mean with, can you please elaborate better? What do you mean with our own network devices? Something that belongs to the UK only?
Yeah, because we don't control network devices in the sense that we don't have the actual hardware themselves, the integrated small devices that link everything together and all our communications together. And I mean, there's a ban on Chinese-made devices, for example. I just wondered why we don't actually find UK suppliers for these things, if that's a security risk.
Okay, it's a very complex topic, this one. It's not just where it is produced, but it's the trust that you have in the supply chain, definitely. Being produced by a specific country that gives less control. I may understand this element. Is the usage of components of the shelves commercial of the shelves we are talking about, of codes. In the railway industry has very often very dedicated and custom solutions, but we use a lot of codes as well. It's critical. I may agree, but we need to know what this element does. If there is a vulnerability that is known in this element, independently from where it is produced, may be important in the context of what we are doing to risk assess, try to mitigate the issues around this topic. I'm not sure this will be the solution, to be honest, because it really depends on the specific case we are talking about. Because if we talk about a device that has both software and hardware, and it's completely out of our control to understand how it works, and then yes, it's a risk, but it's again a matter of trusting the supply chain. It's a controversial question. I cannot fully answer, I'm afraid. I don't think it's the only solution we could have around this topic.
Thank you for your answer.
Lucia. And any other questions from the floor? There's one that's just come in the chat, which is, should the provision for cybersecurity form part of tender submissions for latter-day design and maintenance contracts, given the fact that it is seen as an expense?
Yes. It's happening. To be honest, if we look 10 years ago, then probably just a small amount of contracts discussed about security, or less even. But more and more often, cybersecurity is part of the request at the tender stage already. So I really hope that becomes a strong element that is considered during the tender as well. Not only for people that do the project, that the doer, but the people that request that something is done for their system. Our clients tend to set targets for the safety, for the performances, the RAMs in general. Then, well, it would be great if they have a clear vision and objective around cybersecurity too. But we are going there. We are going in this direction. But it's still seen as a cost. Sometimes also safety is seen as a cost, but it's something that we are getting better and better with.
Well, thank you. Are there any other questions? I take it that's just a thumbs up rather than a hand up.
Yeah, it was for the answer, I guess.
Okie doke. Well, I think we'll wrap it up there then, Lucia. Thank you very much for that really interesting talk, and something that I'm sure the vast majority of people on this call haven't really been involved with before. So yeah, very much appreciated. Thanks for your time. And
thank you for
to all
inviting.
of those who attended.
Thank you for inviting me. It has been very nice. If you have questions you want to ask separately, please feel free to drop me a message, and I'll do my best to answer. Thank you again.